Hello students, welcome to the Yupp Master. Today we are going to take the class for 8th class students. We are having the session that is measurement of physical quantities in various systems. So in the previous class we have discussed about the physical quantities and need of measurement and all we have discussed. How the physical quantities are classified, what is matter and its classifications we have discussed. Now it is very clear, let us go for this topic. Measurement of physical quantities in various systems. Now if you are going to take that, measurement is a one process which has been involved more than one step. That is, if you have taken one physical quantity, choose a standard system of unit and you can express its value in the number of times. It is very clear. So what is the need of measurement? In order to estimate the physical properties of a matter, physical properties of a quantity, just you can take that. So let us have some physical quantities and its measurements in different occasions. Let us go for, if you are going to take a physical quantity like displacement and time and all these things, you have taken that time is a one physical quantity. Suppose the car is at rest position. If it is going to move in a particular direction along one dimensional, now how you will measure that? Its speed and velocity. If it is going to be in one direction, please take that, have a look. It is going to be taken origin, it has been moved along the x. So there exists some displacement. X naught, it is going to be initial position, x is the final position. So how you will measure that displacement? You can take that final position and initial position, you should get the difference and find out that here the time is, you can take that time, it is going to be t1 second. It has been reached that time here, that is t2 second. Now you are going to measure that the displacement and velocity, please take that. That is, you can take that delta x by delta t, that gives x minus x naught by t2 minus t1. So it is the measurement of a one physical quantity that gives that velocity. So these are the final and initial coordinates, that is you can take that x and x naught, that is very clear. Now in order to have the measurement, you need to have that one system. It might be having some direction and it has been chosen in a one frame. It is very clear. Now you are going to get that, you are going to measure that V. Like that you can measure any physical quantity by knowing some parameters and you can express in terms of any system of unit, that is if you are going to take that system of unit, what you can choose that its value. Suppose it is a 100 meter per second, you can take that its value. So the measurement, it gives that, so V is equal to 100 meter. Generally it was expressed as N into U. Generally, what is N? It's a numerical value. What is U? It gives the unit. Thus we can express in any desired system of unit, whether it has in meter, you can express in centimeter also. That's very clear. Now you are going to take that the measurement involves the various steps. That is, you have to approach one step, after that another step, finally you will conclude the matter. That is very clear. Now let's go for another case. If you have been projected a ball, if you have been thrown a ball, just a ball has been thrown by a person, 3 persons. So having the different speeds you should take, and time also, the time gap they have been thrown, at various timing. Yes, you can measure that the speed of the first one, second one, third one also. At the time of measuring, you are going to have that height. You need to measure height also. You need to take that consideration of height, and you need to get that time, and you need to get that initial velocity, and you can get that final. All these parameters, in any case, if you want to measure a physical quantity, these are all very useful. So the measurements has been involved in 2 steps. First step, you have to choose one desired system. Second step, you have to express in a one unit of its value. Now it is very clear. Let's go for another one. You have to see that now. It has been reached that the ground. So you can measure that time taken by that object to reach from a particular height, and you can measure the momentum, and you can measure the force exerted by that body on the ground. All these are going to be measured. Here also you have to take that height, and you are going to take that V final. All these are estimated by knowing their properties. It's very clear. Now let's go for another one. Yes. Initially it has been started from the rest, U is equal to 0, and A, it has been along the direction of Earth's gravity. You have to take that some sign conventions also. That is very clear. A is equal to plus G. These are all the observations which are involved in the measurement of a physical quantity. That's very clear. Height and G. In the downward direction. So very clear, it has been narrated that an object has been fall down in the direction of Earth's gravitation. So it is very clear, you can take that one solid material. How you will measure that? Here you can measure that friction. You can measure the friction. If you are going to take that contact surface area, which can influence that friction. Now you can take that the measurement of the physical quantity depends on the interaction of force and the dimensions and external force applied on the object and all these things. Let's see what happened. You are going to take that, it's going to be moving when you have been applied the force. That is very clear. Now let's go for another one. You are going to exert the force on a area. What does it gives the measurement? Yeah, you will take that force by area. You can take that force exerted per particular area. That gives one physical quantity. You know, pressure, it's going to be taken as force by area. You have taken in the environment the atmospheric pressure. If you have taken that one liquid, it is going to be experienced some pressure due to the presence of environment and the air and all the different external parameters. Now it is very clear, we are going to measure a one physical quantity. You need to know about that, what are the dependent quantities. So if you want to measure a physical quantity, you need to take the dependent quantities also. It's very clear. So here pressure has been derived, it is going to be measured from the knowing value of the force and area. Very clear, you can know that. Now let's go for another one. Yeah, this is a simple method, you can take that. Power. If you are going to take that work done, time, power. Very simple in the calculations. So some electric power consumption. If you drive that and motor to run to lift the water, if you have been continuously operated 1 hour in the time, so this is the time, this is the work done, so this is the power. In this method we can derive that, we can measure the physical quantity. If you want to measure that power, work done, time, simply you can take that power, it's work done by time, work done, power into time. Yeah, you can take that, so taken as T. You can measure this one. So it is very clear, in various aspects we can measure the physical quantities by knowing some other quantities like that. You have to take that. Generally if you are using that iron box, that is while you are ironing the cloths, how it is going to be emitting the heat, how it will consume the power and how much time does it takes to reach a temperature. Some electronic appliances are going to be used to execute the daily activities. At the time you need to calculate the power also, the power consumption and some other cases, right? And you might be having some information about that work done and time, that is very clear. Now it is very clear, if you are going to take that some magnetic flux, simply if you are going to take that, this is a, yeah, you know the magnetic flux, it's going to be originating from one pole to and at an pole. They will start from this one and you can take that. Just you can see that the flux. So this is one magnet. Around the magnet there exists a magnetic field. There exists a magnetic field. So due to the flux, there exists a magnetic field induction around the magnet. Here this is magnetic flux, magnetic flux, yeah, magnetic lines of force. You can take that. You want to measure that magnetic field induction. You know this area is A. You can take that area, and this area is A. The flux, how many number of lines are there, they have been crossed. Let us assume 4 lines are there in that area. So, you can measure that one magnetic field induction V is equal to phi by A. In the limited area, the flux is more, then you can convey the magnetic field induction is more. So, this is flux by area. What is B? Magnetic field induction. It is very clear. So, the measurement of a physical quantity has been involved in different steps by identifying that different parameters which are very useful to calculate that particular value. Right, it is very clear. Now, generally how you will estimate that within a small area the flux is more than a strong magnetic field has been created. It is very clear. So, more flux is, that is a special case. If you want to estimate that magnitude, we will take that. That is not a big task. Please take that. Next one. What is measurement? Let us have a look. In our daily activities, we are having that some need of measurement. Yeah, measurement plays an important role in our daily life. So, measurement of a physical quantity expressed in terms of some standard known as units. What about that standard known units? So, they are going to take that some unique units to express their value. Yeah. And if you are going to take that standard value which is independent of other, it is the same. So, in that system it is same. Suppose you are going to take that unit is a one which is independent of other factors like physical and environmental conditions. If you are going to take that unit, it is the same. Any place, at different places also, if you are going to take that unique units, that standard unit, so its value is going to be same anywhere, right? You can take that. Yeah, physical quantities which can exist independent are called fundamental quantity. You can take that fundamental quantity which is the independent quantity. Some fundamental units also there, they are not going to depend on other. Suppose you have taken that first case force that depends on mass and acceleration. Suppose if you are going to take the fundamental units, they are not going to depend on anything else, right? Now, you can take that. So, the measurement involves in the coordinate system, reference coordinate system. Let us assume that one dimensional. Simply if you have taken a one object, its length is going to be identified. Yeah, you can take that. Yeah, here we can take that length. It is very clear. Here what happened, let us see. Yeah, you have taken that. This is 2D. Based on the arrangement, the measurement depends on the physical properties. The width of an object is going to be less as compared to the length. Very thin, thick, huge object, bulk object. You can take that now. Here, the width, we are not going to talk about that width because it is very less. We are taking length only. Here, we are going to take that area. We are going to take that area. Suppose if you are going to take that another parameter, it is extended to third one. You can take that. This is the case. We can take that area. that is L into B. You can take that third one, which is going to be volume. Yes, please have a look. Yeah, this is 3D. This is going to be this is already you have learned in the lower classes also. Now it is very clear what is the need. You have taken that area, why it is useful. If you know that measurement and if you know the significance, number of lines crossed per unit area, what we have discussed in the previous case. If you know that volume, then you will find out that density, please take that, density is equal to mass by volume. So these are all the dependent quantities. While you are going to take the measurement of a derived quantities, you need to know about all these things. While you are calculating that force per area that gives the pressure. So these are all very useful while you are going to calculate one physical quantity like that, measuring the pressure exerted by an object. You can take that force by area that gives the pressure. You will confirm like that. That is simply F by A. Yes. So the length it plays that if you are going to take that displacement, while you are going to take the displacement, you have to measure the length. If you want to know about different physical quantities, you need to calculate that, you need to estimate that other physical quantities. That is nothing but we are going to obtain the derived physical quantities from other. So some independent quantities are there, some dependent quantities are there. Now area, it is going to depend on the two, length and breadth. What about length? Length is independent. If you are going to take that volume, it's a dependent on three parameters like that. So fundamental units, derived units. After the measurement, you have to express in terms of units. So after the completion of the measurement process, you need to express it in a particular system of unit, whether it is derived or whether it is independent, whether it is dependent or independent, that is a case you need to know that. Please have a look. It is very clear to understand that which one is dependent, which one is independent. So finally you will conclude that in order to estimate the physical properties of a matter, you need to have the measurement. You need to start the process of measurement. It's very clear. But while you are going to take that solids and while you are going to take that liquids, they are not having the particular shape. Yeah, solids are having that regular shape, but liquids, they might be having the shape of the container when they have been placed in one object. At the time you need to calculate that density, you need to calculate that volume. Suppose you know, if you are going to take that iron, you need to take that density, number of atoms per unit volume. If you have taken any material, its density is going to be calculated. It's very clear. In higher classes also you can learn all these topics. Let's go for another topic. Have a look. We have taken that measurement, it's very clear, and we have been expressed its volume. Yeah, we can express the volume in its value by taking the calculations and mathematical calculations also there. Now you can take that. While you are going to look into the three-dimensional view, you need to know about that its size and its parameters are different. Please take that. Now let us have a look. A sphere, it is a sphere, it is a sphere having that center D, and you know you need to calculate that. By knowing that radius, you can calculate the circumference and you will calculate the surface area, and you can calculate the area of the sphere also. It is very clear. Yes. So after doing all these activities, finally what can you do that? You are going to express that final result in terms of two parameters, that is, you can take that. I have been calculated that area of a square. You can take that if the side is 4 centimeter. What about that area? Its area is going to be 4 centimeter into 4 centimeter, that is 16 centimeter square. So here area is like that. It has been compared with the unit that NU. That N represents that value, U represents that one unit to express the physical quantity. It is very clear. Now what do you know about that P, magnitude of the physical quantity? What is N? It is a numerical value. It is very clear. What is U? A standard unit of the quantity, centimeter square. If you are going to take that, if you are going to take that height of a pillar, it is 100 centimeter. 100 is a numerical value, unit is a centimeter. Magnitude is going to be expressed in terms of this equation. Yes, please have a look. Now if you are going to take one important parameter, the magnitude is constant, it does not changes. The magnitude is constant. If you have been expressed in any system of unit, the magnitude is constant. Suppose you have taken one system of unit, you have been expressed in centimeters square, you have been expressed in meters square, you have been expressed in millimeters square. Is there any change in that magnitude? No, there is no change at all. So you can take that it is constant, it is constant, right, very clear. Now you will take that N U is equal to constant. So N is inversely varies unit. So the numerical value is inversely proportional to the degree of the system. Suppose you have been measured that in meters or centimeters, does it varies with the system of units what you have been chosen, higher and lower. It is very clear. Now let us go for another one. Yeah, they have given height of the boy, it is 2.5 meter, how it is possible, yeah, okay, they have given, but you might be having that some persons, that is 250 centimeters, it is an abnormal height, you might be finding these peoples very rarely, 2.5 meters, and it was expressed in terms of 250 centimeters. Here this is N1, this is N2, this is U1, this is U2. Please take. Yeah, you can take in, yeah, you have to understood that matter. Please consider, let us assume we have taken that this is N1, this is U1, this is equal to N2 and U2. You have been expressed that physical quantity height in meters, you have been expressed in meters. This is, yeah, N1 2.5, N2 250, but the system of unit, that is meters, it is in centimeters. It varies that what you have chosen that system of units. In some system it is going to be low, in some system it is going to, but the total magnitude is same, it's very clear. Yeah, that's what you are going to express, that N1 by N2 is equal to U2 by U1. Very clear. So you came to know about 2.5 and 250. You should get that number, it is going to be lower, it is going to be higher, but the total magnitude is same. But here the system of units what you have chosen, meters and centimeter, higher order, lower order, higher priority, low priority, like that you can confirm. In the higher classes it is going to be known that, right. Please let's have a look into another one. So measurement of a physical quantity in various systems. Yeah, you can measure in various systems, like if you are going to buy a one product from different places, that is various parts of the world, you might be having that measurements and its a specification. Sometimes that mass is going to be measured in pound and grams and second, and in MK system also you can take that meter, kilogram and second. So depending on the quantity and its preference, we are going to take that grams. Yeah, simple. If you are going to a gold shop, you might be not asking the 10 kg gold, na? You can take that 1 gram or 2 grams or 10 grams or 5 grams only. Depends on the preference and the value of the physical quantity. Yeah, you might be not asking that kgs, sometimes it is going to take in that. If you are going to shop, just you can ask that sugar, getting that kilogram. That is depending on the situation we are going to take that. Yeah, you never ask that, 1 gram sugar, 2 grams sugar, 5 grams sugar, they will look differently. That depends on that. Yeah, you can take that gold and you can take that sugar. So you are going to get that in terms of grams and in terms of kgs. It might not be encourageable. Can you ask that in that gold? It might be not going to be in the usual practice. Should not ask that, no? Right. Please have a look various systems. Yes, there is an internationally accepted system to follow that common units. That is very clear. So international system of units are accepted in 1971. From that we are all following that international system of units. Yeah, let's have a look. There are the fundamental quantities which are going to be identified, right. You can take that length, mass, time, strength of electric current, thermodynamic temperature, amount of substance, luminous intensity, supplementary quantities are there. So they are going to be added up, that supplementary quantities also, right. in 1991 around that, they are going to be as merged that, right. Let us have a look. Yes, and their symbols also you need to identify that kg. Second, strength of electric current is going to be taken as ampere. Amount of substance and thermodynamic temperature, it is going to be Kelvin. Yeah, and we can take that mole, we can take that candela, we can take that symbols, and so plane angle, it is going to be expressed radian, steradian. So they are going to taken all the units. Generally, if you are going to express that room temperature, that is 27 degrees centigrade. So common phenomena, just temperature, room temperature, yeah, 27 degrees centigrade. Yeah, it can be used as, it can be expressed as, that is 300 degree Kelvin. Yes, yeah, this is a K, that is of Kelvin. We can take that international system of units for their uniqueness. Please have a look. Now let us go for identification, strength of current and thermodynamic temperature. So thermodynamic temperature is one phenomenon. To know about that, change of state related to the thermodynamic temperature. If you are going to change the temperature, the state of the matter is going to be affected. Right, let us have a look. Yeah, a standard value which is used to measure a physical quantity is known as unit. A standard value used to measure a physical quantity. We can take that one standard value, it is fixed. That is, you can take that option. Yeah, unit is that. Yes, unit. You can confirm that answer option C is the correct one. Yeah, all that scale, meter and second, all these are the, it is an instrument. It is also one instrument to measure. Yeah, meter, second, these are all the wrong options. You can take that unit because it is going to be having that some standard value to express that physical quantity. Yes, please take that. What are the desirable features of unit? Yeah, if you are going to take that, it is constant and we can produce that unit. It is going to be consistent. It's correct. Consistent. Consistent means it is going to be constant. Very clear. Now it doesn't change anywhere in the universe, it's going to be constant. You are not going to differentiate it from place to place. In all the places it is going to be same, but its magnitude is going to be changed, but its unit is same. It's very clear. Now let us talk about that. It is correct. First one is correct. Let us go for another one, reproducible. Yeah, what is meaning? Yeah, let's have a look. And yes, we can take that. Suppose, yeah, height of the boy, it is going to be 2.5 meter. Again, you can express in 250 centimeters, and you can have that some it has been produced, right. Now you can take that unit is reproducible, it's going to be known. Yeah, that is also correct. These two are correct, first one is correct, but variable is not correct. Consistent and reproducible, right. That the magnitude is going to change if you are going to take that weight of a person. From place to place, its value, its magnitude means value, it changes. If you are going to take that from one planet to another planet in the universe, the weight is going to be changed. That's a value, it's going to be changed, but units are going to be same. Very clear? Now let's go for another one. Among the following, the odd one is, while you are talking about that different parameter, take that, yeah, first one, let us take that pound. It's related to weight. Yeah, quintal. It's also related to weight. You can express at different places, they are going to express in the different system of units. In one system of unit, suppose you can take that, yeah, in FPS system. FPS system you can take. This is the one. You can take that. This is also one unit. Quintal. It is going to be having the conversion. Now you can have that ton. You can take that. Yeah, there is a related. It's going to be convertible. Yes, you can take that. Yeah, there is a one relation in terms of this weight. That is, if you are going to take that, the magnitude is same, but whether you have been expressed in one system and another system also. Let us take that ton. Quintal. If you are going to take that 100 kgs, if you are going to take that 1000 kgs, that is going to be expressed 1000. It is very clear. Its value is going to be clear. Now let's have a look. It is very clear. Now you are going to discuss about that. This is also related to weight. What about third one? Third one is the angstrom. Yes, third one is the angstrom. Now it's going to express value. It's very clear. You can take that. This is the atom. Yeah, these are all going to measure that macroscopic. These are all going to be macroscopic phenomenon. These three are dealing with the macroscopic phenomenon. But this is atom, which is microscopic. Now, if you are going to take that, angstrom is a one parameter which is used to represent the radius of one atom. Its value is going to be 10 power minus 10 meter. So 1 angstrom is equal to 10 power minus 10 meters. These are all macroscopic, as these three are going to be one which represents the weight and macroscopic, but angstrom is going to represent that radius of atom. They are going to represent that radius of atom. It is very clear. So this is going to represent the length. This is going to these are all going to represent the weight. Now we can differentiate among all, which one is odd one? Angstrom. It is very clear. Now we can discuss that very deeply, microscopic and macroscopic, how we are having that measurement process. It's very clear. Please, all of you, we have the continuation monitoring. All the people has to look into the matter of these animated classes, and well crafted and modern teaching methods are applied to deliver the subject to all the students. So what is your duty? You have to inform to all your well-wishers. It's good to know and let them to grow to achieve their goal.